In this section, we'll cover some basic arithmetic operations for different number systems. We'll be particularly interested in how it works in binary. Now, if you're old enough, you might remember a program called Schoolhouse Rock. If you're not old enough to remember Schoolhouse Rock, head on over to YouTube and check them out to see how addition and multiplication work in decimal. Don't worry, I'll wait. After checking out Schoolhouse Rock, I'll assume you're comfortable with adding numbers in base 10. When you're using a base other than 10, it's important to make sure that you are using only the allowable digits and to keep track of your carries and borrows correctly. Let's take a look at how addition works in binary. Adding two binary numbers works in the same way that addition does for base 10, except here we only have 0 and 1. A carry occurs if the sum in any position is greater than 1. In the example you see on the right, there's also some special terminology. The first number is the augend, the second number is the addend, and of course the last number is the sum. The rules for subtraction are the same as they are for decimal. Here a borrow into a column adds 2 to that column. Like addition, there are some special terms here. The first number is the minuend, and the number subtracted from it is the subtrahend. The result is known as the difference. One issue we might need to be aware of is the case where the second number is larger than the first. If that's the case, we subtract the minuend from the subtrahend and put a negative sign on the result. That is, we reverse the order that we do things and make the final result negative. So, as you might expect, binary multiplication works just the same as it does for decimal, except here it's even easier since the only numbers are 0 and 1. 0 times 0 is 0, and of course 1 times 1 is 1. Arithmetic operations with octal and particularly hexadecimal may require you to create tables with the appropriate results. If you're doing addition or multiplication in hexadecimal by hand, it may be worth converting each pair of digits to decimal, adding them, and converting the sum and the carry to base 16. The same trick of working in decimal can work for multiplication very well. Take a look at this example of octal multiplication. In the first step we have 5 times 2. Well, we can do that in decimal. That's 10, or 1, 0. Now that's an 8 plus a 2, so that's 1, 2 in octal. So we put down a 2 and carry a 1 into the next column. If we were doing this with more digits, we would repeat it step by step until we're finished with the multiplication. Well, that's a fairly short take on this one. The examples in the text are covered in a bit more detail if you want to check those out, and also make sure to check out Schoolhouse Rock and practice your addition and multiplication. You'll need them.